And if we wanted to take this value of z and raise it to an exponent, then you obviously have to raise the exponent of what's on the inside. So you bracket it out. To the nth power. And then all that happens then, as you basically think of it as in terms of just almost a distributive property for that exponent. This is the last bit of 6.5. It's called de Moivre's. I don't even know how to spell de Moivre. Who's French? Anybody is French? How do you pronounce that in French? How do you pronounce that in French? Is it de Moivre? 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 Like suave?
It's Moivre.
Moivre?
Can we just call him Abe?
He's not one of the turtles.
His first name's Abraham.
He's using turtle.
That's funny. Who's the Abe's theorem?
What's his first name?
Jump raised to a power. So it's a complex number raised to a power.
Abraham Lincoln.
That's all.
Yeah. You know, man, what's the practical? That's how
So you wind up with this.
Why?
It looks really weird, and like I said, you guys are going to have a note card to be able to write down your theorems. It's just a matter of being able to utilize it. Notice what happened there. Basically, you've taken the exponent, some n value, and you've distributed it to the terms that are within, that were within the parentheses.
You forgot your second parenthesis.
Sorry. So it looks kind of like that. So let's take a power of a complex number, and let's use -1 plus √3i to the 12th. Yeah, because remember earlier when we started with standard form, we went to complex form, you had to find the r value, find the angle. You're doing the same thing. Okay, so you're going to set it up to find that r value like we did before. We place it just like we did in the axis. We know what quadrant we're going to wind up being in. That way we know whether the angle's going to be positive or negative. What quadrant is this going to wind up in? As he goes -1 and up to √3. It's going to be up here. So we know that. So we know that when we find our value of r, remember r is going to be found by the square root of -1 squared plus √3 squared. And that gives us how much? So it becomes 2. So your r value is 2. Notice we're setting it up. We're starting the same way we did last week by finding the value of r, giving it a plus. So like I said, we're starting with the same way that we did before. You find that value of r by using Pythagorean theorem. And then we're going to find theta by using the inverse tangent. Okay? So if we went over -1 and we went up √3, so what angle has a tangent of √3 over -1? What triangle gives you the √3s and 1s for tangent? 30, 60, 90, good. So remember, in a 30, 60, 90, which one of those is going to give you the √3 over 1? It's 60. So that is, in terms of radians, pi over 3. But I'm in the second quadrant with a reference angle of pi over 3. What's theta? Reference angle is pi over 3. So it's 2 pi over 3. Good. So theta
I thought it was wrong. That's why I didn't
is 2 pi over 3. Okay? So the standard trig form of this, to start out, is what we've just been able to do. We're able to rewrite the complex number into trig form, substitute in your r and your theta. Move this up a bit here. We get 2 cosine 2 pi over 3 plus I sine 2 pi over 3. You okay with that? Now we just raise everything to 12. So now if I want to do to the 12th power, z to the 12th, that just means I have to follow the law of the rule. If I go z to the 12th, it means it's going to be r to the 12th, cosine of 12 times my theta, I sine 12 times my theta, because the value of n is 12. So we get 2 to the 12th, cosine of 12 times 2 pi over 3. I'm going to do this long form first before I simplify all these fractions on you. And I have that. You okay with that? Yeah. Because it's going to be to whatever power. The power is the nth power. Bless you.
Thank you. So then,
Yeah, now we figured it out. So 2 to the 12th, 4096, I think.
I have flowers.
I may have pink eye, but I still have brain. Next I ever wrote it down.
Oh.
I tried to sell it. There's no way in hell I knew what 2 to the 12 was.
Well, he like, it's 4096, right? Like, we knew.
I tried.
All right.
And then when you simplify out the 2 times 12, so 12 times 2 is 24. 24 divided by 3 is 8. So this becomes cosine of 8 pi plus the I times the sine of 8 pi as well. Everybody with me so far? 8 pi. Will 8 pi land somewhere helpful?
Yeah.
It's going to land on quadrantal, I believe, right?
Yeah.
So let's figure that out. We count our pies. 1 little, 2 little, 3 little pies, 4 little, 5 little, 6 little pies, 7 little, 8.
Get this, like, 8 little pies.
So you have 8 total pies, which means what's your ordered pair
1.
at 0? It's 1 and 0. Bless you. So what's the cosine of 8 pi?
1.
1. What's the sine of 8 pi?
0.
0. What's your answer?
4096.
Go to the next problem.
Can you just leave it like that, or do you want us to write like? or-
You'll write it out, because not every time you're going to wind up where you get 1 and a 0. Okay, you might be placed into a special triangle. You might be placed where you have to get a decimal.
Shut up.
And you just write it out. Why are you so shy? So really, what happens here? It's just it's an extension, expansion, a better term, of what you guys were already doing by going from standard form to the trig form, and then it's just using that exponent, which winds up being really nothing more than a coefficient for thetas, and an exponent for the r value. Okay. Let's try another one. Not erasing, not going too fast. I'll slow it. We will. We will. Oh yeah.
Yeah, I'm about to get another 42%. Yeah, once I told my mom kid I had an F in this class, she gave up.
All right. Let's try another one.
Okay. Okay. This is the last.
Yeah, I'd like to try and. There's one other little piece.
Let's not strain our brains.
I don't know if I'll have time today to get to it, so I might just wait and do that later. Let's do the same basic idea. Obviously, again, what you have to start out with is going from standard form, figure out your R value, figure out your theta. 3 minus 2i gets you put to what quadrant?
4.
4, very good. So we know it's going to be a quadrant 4, so when we do tangent, will tangent be positive or negative in that? So we didn't worry about doing all that other junk then. So we wind up with our R value is the square root 3 squared plus negative 2 squared, which gives you the square root of 13. Tangent of theta is going to be, was it negative 2 over 3? So what angle has a tangent of negative 2 over 3? Well, obviously that doesn't wind up into a quadrant, or it doesn't wind up on a special triangle. This is where we wind up using our calculator. Okay. Negative 2/3 is going to get us to a calculator part, all right? So we're going to figure out that value first. Okay. So we do the inverse tangent. Make sure you're in degree mode. I think by now most of us have defaulted to degree mode on those.
We've struggled.
So with inverse tangent, what, negative 2/3? 30, negative 33.69.
Okay, I got oh. Oh, no, I didn't.
There you go. So now we know that our theta value is negative 33.69. And it makes sense that it has to be negative because tangent's negative in that third quadrant, or excuse me, fourth quadrant. And our R value was the square root of 13. So you write out standard trig form to start. And standard trig form was, yeah, two. Well, if you go 2 places is fine. So you're going to have this be the cosine then of negative 33.69 plus I sine negative 33.69. That would be your regular old boring trig form. Since you're using de Morvet, so once you raise everything to the exponent, un baguette. It is a lot of fun to speak French, though. Didn't I do that last year? I swear. One class must have just talked French all day.
Really?
Yeah, I probably
It
was.
probably was. I was even called it
Probably, yeah.
I love Irish.
So this just looks awful. Okay. It looks awful. So you chunk it apart into smaller bits. What you want to do is type in the calculator. We're going to do the cosine of 8 times negative 33.69.
What?
With the sausage.
So if we do this, we go cosine 8 times negative, what was it, 33.69 Now, we're gonna get a little rounding here, I believe, here. Technically, we should be typing in we should type in the inverse tangent of -2/3, because you won't have the rounding error, but whatever. So I'm getting -0.008377. Do the same thing for sine.
Sydney, he catches you literally every time. Cameron, I got the same thing.
I know, it's weird. I know.
No, I don't. Okay, I got
You're gonna get 239, -239.
-239, sweet.
Yeah, you're right, you're right. So now I have to take the square root of 13, and you go to the 8th power.
Cameron, what did we do? Yeah, it's wrong. Oh wait, no, I got that. Never mind. Yes.
So on the outside, if I take the cube root, the square root of
Keep rolling
13,
less in the things.
and I raise it to the 8th power, I get 28,561 times some mess inside the parentheses. Okay? Just distribute that to both those parts. So times, was it
Can you
negative?
just round the second one to 1 or no?
No, I wouldn't, because you're going to get something different.
Oh.
You should get something different. So
So you want us to go off the whole thing?
I would try to. I'm getting -239.26 plus. Now, all right,
If we round by 1 decimal point.
you're going to be close enough, okay?
So we don't.
Here's the thing that happens with the calculator in this problem. If you use the calculator and don't do any rounding error at all, if I just typed in, at this point, instead of using -33.69, that was the inverse tangent of -2/3. If I did cosine of 8 times the inverse tangent of 2/3, and then multiply that by 28,561, you get an exact answer of 239. So it really depends on how you round your stuff through to make it work, to make it go. Okay, that's how it works.
Didn't wait.
Here it goes. So you get -239 and change, and then you wind up with, I think it's also negative on the other one, isn't it?
Good catch.
Something like that, somewhere in that neighborhood.
Yeah, I got it. But I didn't get mine.
Yeah,
Well, I
and
didn't-
the same deal. It's
But you're not gonna mark that wrong.
this is where it comes in. You have to kind of show it work. I'm just showing you guys. I wanted to show you an example where you use your calculator, and depending upon how you set it up with the rounding, how it can vary ever so much. I mean, we rounded and we're off by a 1/4 point if I didn't round at the beginning. And I wrote it out to, 6 decimal places? Writing something out to 6 decimal places, I'm still off by a 1/4. So it's crazy. Basically, it boils down to show your work. Show me that you know what you're kind of rounding themselves out to do before you type everything in. Because these problems can get messy. The process isn't difficult to go through. You just gotta be careful with your the way you type it in. Not sure.
I'm 100%
We
sure.
do one more of these with a different value out in front. Okay. Am I okay? We okay?
Wait, are we doing more stuff after this one problem?
I've done one for
I
years.
don't have any more room on my paper.
Turn the page.
No, because it's back. Exactly, so I don't want to use.
In Vegas, the number for
Really?
is not.
No, just kidding, I didn't.
It's 877.
I thought it was a question mark at the top, not a seven. And I was like, I thought you said you had to tell us what that was.
Yeah, I did. It's a 7.
I know, I thought it was a question mark
But they tried.
Okay, do you just-
at the end.
You do that for work operations? Nope. Please excuse exponents go first. All right, same deal. Start it out with your, find your R value.
Yeah, you want to start.
Square root of 3 squared plus 1 squared, because the coefficient of I is 1. So I get an R value of 2. 1, or root 3 and I is quadrant 1. So the tangent is always going to be B, we figured out with B over A. So 1 over root 3, what angle has a tangent of 1 over root 3?
30.
To 30 degree, otherwise known as pi over 6, very good. So our R value is 2, and our theta value, pi over 6. Fill in the blanks in terms of Z. Your trig form. We get 2 times 2 cosine pi over 6 plus I sine pi over 6. And then I raise everything to the 7th power. Well, what do I have to do about that 2 all the way up the front? Just leave it outside. Just leave that 2 on the outside. You're going to work with all the other stuff on the interior. Okay. Since we're going to the 7th power, z to the 7th is going to be 2 to the 7th cosine of 7 pi over 6 plus I sine 7 pi over 6. Yeah, remember it's 7 times theta. So n times theta. And it's just so in this case, theta is pi over 6, so it's just 7 times 1, 7 pi over 6. And then think about where 7 pi over 6 winds you up as far as a quadrant. 5 and 3, very good. It is, yeah, reference angle is still pi over 6. It's in the 3rd quadrant. So is cosine positive or negative in the 3rd quadrant? Negative. Okay. So the cosine of pi over 6, remember, if we go back and look at your triangle, cosine of 30 would be root 3 over 2. But it's in quadrant 3, so it's negative root 3 over 2. Yeah, you can if you want. So you get 2. 2 to the 7th is what? 2, not 256, it's 128. That one I knew that. Because I knew 256 was 2 to the 8th, so I just cut it down. Right? Why do I know that? So the cosine of 7 pi over 6 is negative root 3 over 2. The sine at 7 pi over 6 would be negative 1/2. So we'll say it's minus I times 1/2. Is it okay to write it like that?
I'm so confused why you just leave one
I
side.
didn't.
Oh, because never mind. I got it.
Okay. So on the, oops, I need another parenthesis. Distribute this in here, I get a 256. And then I have negative root 3 over 2 minus I over 2. What can I take out from inside the parentheses? Not 2, 1/2. So what's half of 256? 128. So you have 128 times negative root 3 minus I, which is negative 128 root 3 minus 128 I, as you distribute through it to finish out. It looks so much more overly complicated than it needed to be because you're still doing the same stuff. You're taking your A plus B I and you're converting it by finding the R, which was A squared plus B squared. You're finding tangent, what angle has a tangent of B over A, and that gives you theta. You're still doing all of those steps and figuring out what quadrant they're in and going through it. The only thing really winds up being different is when you have it raised to some exponent, your R value gets the exponent and theta gets the exponent. Not, I shouldn't say the exponent, it gets multiplied by it. Okay? And that's how these things work out. If you give me a second after I put up the couple of problems I want you to do here, I forgot to grab note cards. I'm going to give you guys note cards today so we can make sure we have them and all that so you can start putting them through. All right? Yeah, what I want you guys to do instead, because I actually want to change it again, because we did not get the other. Yeah, I'll just do those. Time to do the other stuff. Can I go to a clean one and put down the problems?
Yeah.
So this is all the Demave. So it's 6-5, still the same page, something or another. Those 6, it's 479. And if you want, I can do this.
6.5?
Yes, ma'am.
Oh, yeah, you're wrong.
I'll just throw these on here so you
The
can.
board's not updated yet, they're gonna run it back. There we go.
Alan, why didn't you comment?
What are other plans? You guys were like half an hour.
Did you actually talk to her? She didn't even talk to her.
It was a good time.
Yeah, heard you guys big one.
What'd you do instead?
You're doing all kinds of stuff.
I know.
Are you saying you want me to be the nicer person for longer?
Yeah,
I like the real person.
Not this watered down, not this watered down fake one.